All right, so welcome to this, your lesson on what are the properties of quadrilaterals. So what we're gonna do is we're gonna go back one page, okay? And we are going to take a look at some of the properties of the quadrilateral family tree. So let's start with the first one. The first one is named the quadrilateral, and we're gonna look at the properties. Well, it has four sides. That's it. Wow. So the quadrilateral has four sides. Yes. Now let's think of this as the ancestor. Okay. Think of it as the great grandmother of all quadrilaterals. So she gave birth, right? And when she gave birth to two sides. The ugly side, okay. As you can see over here, this is the ugly side right here. Okay. And the beautiful side, which is the one that is aesthetically beautiful. All right, so let's see what her first son looked like. So she gave birth to the parallelogram. Now the parallelogram, what can I say about the parallelogram? Well, notice that the opposite sides are parallel. That's why it's called a parallelogram. And also, opposite sides have the same length. That means that they are congruent on the parallelogram. Okay, opposite sides are congruent. What else? Well, opposite angles are congruent. When they say opposite angles, they mean this angle right here, okay, being congruent to this angle right here, or this angle to this angle. Those are opposite. In other words, not on the same side or non-adjacent. Got it? Okay then. What else? Well, consecutive angles are supplementary, meaning that this angle with this other angle, okay, these are consecutive, either this with this or this with this. In other words, it's like on the same side. You see that? Like this angle and this angle are supplementary, meaning that they add up to 180 degrees. Okay, so 180 degrees, I could just put here 180 degrees just for the sake of doing it. One more property is that diagonals bisect each other. Diagonals, remember, diagonals go from one vertex to a non-consecutive vertex. Wow, I'm trying my best. So this is a diagonal, so please trace it. And let's trace the other diagonal. Okay, I did my best. Hopefully it looks accurate. So these diagonals bisect each other, meaning what? That they go through the midpoint, and therefore it makes this segment congruent to this segment, and makes this segment, I'm gonna put 3 hash marks, congruent to this segment. All right, don't forget that. So let's see what we learn about the parallelogram. So opposite sides are parallel, opposite sides are congruent. Okay. What else? Diagonals bisect each other. Opposite angles are congruent. And consecutive angles are supplementary. All right. So anyway, so after a while, she found another quadrilateral, and then they had, kids, right? So she gave birth to the parallelogram, gave birth to the rectangle and the rhombus. Okay, now watch this. These two kids are different, but at the same time, they are similar. So, the rectangle, what do I know? Hello, 4 right angles. Do I need to say it? Also, diagonals are congruent. If you do these diagonals right here, okay, and this other diagonal right here, and you measure them, you will see that they have the same length. All right then. Now, what else? I mean, come on. Kids, they always inherit something from their parents. Well, it did. The rectangle did. It has all the properties of the parallelogram. It has all the properties of this parallelogram. Plus, of course, every kid has its own traits. So, watch this. Opposite sides are parallel. Opposite sides are congruent. And also, I guess, opposite angles are congruent. Consecutive angles add up to 180. They're supplementary. Diagonals bisect each other. And on top of that, I got 4 right angles, and the diagonals are congruent, which they were not in here. This diagonal is longer than this one. Make sense? Okay, so let's take a look at the brother. All right, so the brother is the rhombus. Look at this guy. Remember, this is the son of the parallelogram. So it has all the properties of the parallelogram plus its own. It has 4 congruent sides. Starts looking like a square. Yes, Becker, you're nice. Okay, it looks like a square, but it's not. Perpendicular diagonals. Holy smokes. So if I do this, if I trace the diagonals like this, like the way you're doing right now, try to do my best. I'm far away from this, and I think because of this, I'm gonna need glasses. Okay, so these diagonals are perpendicular. See that? Okay, perpendicular diagonals. What else? Diagonals bisect opposite angles. Oh my God, so we need to know all this. Okay, the rhombus has a little more properties than expected. So let's see now. Perpendicular diagonals, we know. 4 congruent sides, yes. Diagonals bisect opposite angles. This diagonal right here acts as the angle bisector. So this angle is congruent to this angle. This angle is congruent to this angle. And not only that, this whole angle, opposite angles are congruent because it inherited all the properties of mother parallelogram. And of course, again, diagonals bisect each other. Opposite sides are parallel, opposite sides are congruent. Consecutive angles are supplementary. What else? No, I think I said everything about the rhombus. Now, they both decided to experiment. And they gave birth. Okay, they got married and all that with other quadrilaterals. And they both happened to give birth, okay, to the perfect breed. This, the square. And what are the properties of the square? Need I say that is all of the above? Meaning what? Oh my God, where do I start? Okay, opposite sides are parallel. Okay, opposite sides are congruent. Diagonals bisect each other. Diagonals are congruent. Consecutive angles are supplementary. Opposite angles are congruent. Am I missing something? As 4 right angles. Gosh, diagonals are perpendicular. Woo. Diagonals bisect opposite angles. I mean, all I'm doing right now is just looking at the other ones and just mentioning all of those properties. So this is the perfect beam right there, the perfect polygon. Okay, so we looked at the nice side of the family. Now, we're going to have to look at the ugly side of the family. So, again, quadrilateral, Homo sapiens, Australopithecus afarensis, that's the caveman right there. So, he gave birth to the trapezoid. So, what are the properties of the trapezoid? Well, remember, the kid actually inherited all the properties of the quadrilateral, which basically was only 4 sides. So, trapezoid has 4 sides. One pair of opposite sides are parallel. Which one? This one? Hell no. Oh, okay. So this is parallel, and this is how we denote parallelism, right? Oh, okay. So parallel. The leg angles are supplementary. The leg angles are supplementary. Which are the leg angles? I'm not sure. Supplementary. The leg angles are supplementary. This doesn't look supplementary to this. This doesn't look supplementary to this. Leg angles. Well, what are the legs? These are the legs. They didn't say base angles. They say leg angles. I'm confused. Oh my God, now I understand what it means. This is one leg, so this angle and this angle are supplementary. This is the other leg, so this angle and this angle are supplementary because they add up to 180. Oh my God. All right, confusion is over. All right, so that's it. That's basically that's it. That's all I know about this. All right. Then this trapezoid gave birth to the isosceles trapezoid. And now, what are the properties here? Well, it has four sides like the ancestor, and then like the mother, a pair of opposite sides are parallel. Also, leg angles are still supplementary. Okay. What else? Okay, now we go with the new properties. Legs are congruent. These are the legs and they are congruent. Okay, makes sense. And one of the proofs that you could do is extend this side right here, extend this other side right here, and you will see that it forms an isosceles triangle. Okay, cool then. What else? Base angles are congruent, diagonals are congruent. Wow. Be careful with this. This is the isosceles trapezoid. Okay? Not just the trapezoid. And why am I saying this? Because if they ask you in a trapezoid, the diagonals are congruent, and you go like, yeah. No, only in the isosceles trapezoid. Not here, here. Not here, here. Okay. And now, the last but not, wait, hold on a second. Where is this coming from? Yo, look at that. Great-great-grandma quadrilateral got busy. She gave birth to the kite. Oh, gosh. All right, no problem. So let's see. The kite, being a direct descendant from the old quadrilateral, inherited all the properties, which basically is just has four sides. So now let's see, how did this guy come out? It has two pairs of adjacent congruent sides. Two pairs of adjacent congruent sides. Oh, sorry. Come on, come to me. Let me see, can we come on there? Nope, that's it, I got it. Okay. This is because the paper is too little. All right, two pairs of adjacent congruent sides. Adjacent means sharing the same vertex. So we're talking about this congruent to, well, hello, it's not going to be congruent to this one. Congruent to this. And this congruent to that. Okay, fine. What else? Opposite sides not congruent or parallel. This is not congruent to this, and this is not congruent to that. That's what the kite is. Now, you know what? Let's take a look at one of the properties that I think we missed. And it is about the diagonals. Diagonals. Let's look at it this way. What do you notice? Diagonals are perpendicular. Okie dokie, and this concludes, this review of the quadrilateral family tree. I hope you had fun, because now we're gonna look at a chart, okay, that is right here. Now you wanna see how small these drawings were really? I'm gonna show you. So look at that. That is how small they were. Exactly, right? And if I was to read them to you, if I was to just draw them like that, you would go crazy. But anyway, that's something else. All right, so let's take a look at our family. So here is what we have in this diagram. The quadrilateral is like the oldest, right? Then it gave birth to the parallelogram. Then the parallelogram gave birth to the rectangle and the rhombus. And between the rectangle and the rhombus, they came up with the square. That's the pretty side of the family. Then, of course, from the quadrilateral, we go to the trapezoid. From the trapezoid, we go to the isosceles trapezoid. And She got busy, so we got the kite. Now here what you have is a checklist of all their properties just in case. Okay, so for example, I'm not gonna go through all these because really properties. For example, opposite sides are parallel. So parallelogram, yes. Rectangle, yes. Rhombus, yes. Square, yes. We know that the kite doesn't have any parallel, opposite sides parallel. Neither does the trapezoid, neither does the isosceles trapezoid. Wait. Oh yeah, okay. I understand. Isosceles trapezoid says that one pair of opposite sides is parallel. Okay, we know that. So let's see. Opposite sides are congruent. Once again, parallelogram, rectangle, rhombus, square. Opposite angles are congruent in all of them except for the kite, the trapezoid, and the isosceles. Okay. Diagonals form two congruent triangles. Okay. So we got where is it? Two congruent triangles. And the parallelogram, yes. And the rectangle, yes. All of them except for the kite. Okay. Trapezoid and isosceles trapezoid. All right. Let me see. Diagonals are perpendicular. Look. On the kite, they are perpendicular right here. Ha! Yeah, you try to trick me, but you couldn't. Anyway, this is just, a table of check marks based on what we just did. So let us move on to the aim. So here, what you're gonna do is you're just gonna mention, as many quadrilaterals as you know. I can tell you right now. I can mention the square, the kite, parallelogram. What is this? Trapezoid, isosceles trapezoid, rhombus. Did I mention square? Yeah, I think I did. All right. So that's what you got. Okay. So this problem right here. Okay. I'm supposed to find the measure of angle X. Sure, why not? Measure of angle X is I have to add all the exterior angles. Okay, so 68 plus 84 plus 60. I need to know what this exterior angle is, which I already know based on the fact that we did this problem before. So this is a straight line. Well, a ray, of course, because it only has one arrowhead. But this interior angle is 140, so this exterior angle is 40. Okay, cool. And now I just add them all up. Okay. And the answer would be, it would be nice if I could find the answer. Okay, give it to me, because I really don't know what it is. Got it? Come on, do it before I do, and I'll give you the point. All right, so we got it, right? So this is 108. The answer is 3. We got you with this. Let's move on. All right. So, in which polygon does the sum of the measure of the interior angles equals the sum of the measure of the exterior angles? It has to be the quadrilateral. 360 on the outside, 360 on the inside. I mean, no questions about it, right? All right. And now we're going to the semi-independent practice. Oh, yeah. May I have some fralies? No? Okay. What does it say? It says, in the diagram below, parallelogram ABCD has diagonals AC and BD. Okay, cool. That intersect at point E. Okay. Which expression is not always true? Well, let's take a look at this. Angle DAE. Angle DAE. Is my thing sharpened? Let's see. No, it's not sharpened. I need to sharpen this. So just give me a second. I just have a whole mess in here, but give me a second. I said a second. A minute. Okay. Oh, beautiful. All right, where was I? Oh, yeah. So, angle DAE, Well, you already solved it, I guess, because while I was sharpening my pencil. DAE. DAE. This angle right here, okay, is congruent to BCE. BCE. This angle right here. Guess what? Yes, they are. Now, I didn't mention anything on the properties of quadrilaterals, but guess what? What do I know? This is a parallelogram. Parallelogram, opposite, okay, two pairs of opposite sides are parallel. So this is parallel to this one. Therefore, if I extend the sides, just, you can always extend the sides. It's a legal move. Guess what? Then this becomes a transversal. Okay? Or actually, this becomes a transversal as well. Anyway, so these are alternate angles. See that? So these are alternate interior angles of these two sides. Make sense? Please tell me it makes sense. So alternate interior, so that's true. Okay. AC is congruent to DB. AC, what is AC? AC is congruent to DB. First of all, it doesn't say on the property. If you look back on the properties of a parallelogram, okay, it never says that, sorry, you cannot see it, but it never says that the diagonals are congruent. So therefore, this is not always true. Oh my God, I didn't ask you to give me the answer. Oh, it doesn't matter. Okay, cool then. Let's move on to the next problem. It says, as shown in the diagram below, the diagonals of parallelogram QRST intersect at E. All right, so what? If QE is x squared plus 6x and SE is x plus 14, okay, so what? And TE is blah, blah, blah. Okay, fine, I get it. Determine TE algebraically. Oh, gosh. So I'm supposed to find TE. All right, what do I know about the diagonals of a parallelogram? Okay, give me the properties that on the diagonals of a parallelogram to see what's up over here. What do I know about the diagonals? Do they... yeah, exactly. Diagonals bisect each other. If they bisect, that means that they split each other at the midpoint. Therefore, this side is equal to this, this segment equals to this segment. And this segment equals to this segment. Therefore, if this segment equals this one, I can find x. Okay, see? That's called common sense. Let's start working with this. I have a whole mess in this little room. So what am I going to do? I am going to equal this to this. So I'm going to say x squared plus 6x equals x plus 14. And now I notice something. This is a quadratic equation. Therefore, I'm going to equal it to 0. So I will subtract x from this. I'm going to make this side 0. So I'm going to subtract x and I'm going to subtract 14. Okay? So what you do to one side, you do to the other. So minus x minus 14. And since I already subtracted it from here, then the result was 0. Make sense? Okay then. Now, what am I supposed to do? Well, now I am supposed to add the like terms. So let's add the like terms. So what do you get? Ta-dum, 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 ta-dum. Okay then. So we have x squared plus 5x, because 6x minus x is 5x, minus 14. All right. If you can factor, I'm going to give you 30 seconds. If you can factor this before I do, then I'll give you 1 point. All right. Hopefully I paused it and nothing happened. So I'm going to factor this. So boom, 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 boom. Okay. So factors of x squared, I already know. I'm tired of doing this time after time. Factors of 14, 7 and 2. It was that obvious. All right, now I need positive 5 and I need negative 14. So positive 7 minus 2 is positive 5. And positive 7 times negative 2 is negative 14. So we're good with this. Now I equal each of the factors to 0. So x plus 7 equals 0. And what number plus 7 is 0? Negative 7. X minus 2 equals 0. So what number minus 2 is 0? Or you could just solve for x by adding 2 to both sides. And anyway, so x equals 2. We disregard the negative value because we're measuring distance and it cannot be measured. So, okay, we discard that one. And now x is 2. Question is, what is the measure of TE? Well, x is 2. So TE, where is TE is right here. TE is 6x minus 1. So 6 times 2, so I'm going to write it over here. TE equals to 6 times 2 minus 1. Okay, 2 is x. And then TE equals to 12 minus 1. And please, you already know what the answer is right here. Okay, so TE is 11. Let's move on to the next problem. All right. So, which statement is true about every parallelogram? All 4 sides are congruent. That's BS. Only on the square and on the rhombus. Okay, the interior angles are all congruent of a parallelogram. All? No, that's only on the square and the rectangle, I think, because they're all 90 degrees. But in this is a parallelogram right here. I don't think this and this. I don't think this is 100 either. Got it? So no, they're not congruent. Okay. Number 3. 2 pairs of opposite sides are congruent. Bingo! But hey, let's go to number 4. The diagonals are perpendicular. No. The only ones that have perpendicular diagonals, I think, are the rhombus and the kite. Oh wait, not the rhombus. Sorry, the square and the kite. All right. So the answer is number 3. All right. Here, what do they want? In the diagram below, this is a rhombus. Okay, so guess what? Just by saying that it's a rhombus, I can already say that these all sides are congruent. What is the measure of DBC? Angle DBC. DBC. They want this measure right here. Funny thing. Okay, so how do I do this? Becker, you're overcomplicating yourself. Look at this. This is a rhombus, but look at the small picture right here. This is a triangle right here. And look at these 2 sides. These 2 sides are congruent. Therefore, this is an isosceles triangle. Therefore, this angle and this angle are congruent. So this is 40 and this is 40, because in a triangle you can only have 180 degrees. So I hope you understood this explanation. All right, next problem. If the diagonals of a quadrilateral do not bisect each other, then the quadrilateral could be, well, if they don't bisect each other. They do, they bisect each other on the rectangle, they bisect each other on the square, they bisect each other. Please, it's gonna be a trapezoid. Nice, right? Yes. Okay, what else? Now let's move on to the next problem. Oh, I solved this one already. Okay. Gosh, I have a mountain of papers here. Oh my God. I really need, they're gonna kick me out of the house. And the city is gonna charge me money for not recycling here. Alright, anyway. So in rhombus ABCD, okay, the diagonals AC and BD intersect at, oh gosh, I don't have a visual, so I'm gonna just draw a visual, okay? So I'm gonna draw a rhombus. So what do I know about a rhombus? That sides are congruent. So I'm gonna do this, and somewhere in here I'm gonna do this. Oh shoot, I gotta do the same thing here. Okay, fine. 1 inch. Okay, and now I'm gonna do the same thing here. 1 inch, and that is gonna help me. See that? It helps me create the 4th side. Nice, Beck. Oh gosh, you're all nice. Okay, I want to now let's talk about this. So rhombus ABCD, a B, and see, I didn't say a B, I said a B, and D. Okay. So now diagonals AC. All right, so I did it right because if I connect A and C, I'm gonna get a diagonal. See, and I'm assuming they're gonna ask me for the other diagonal. I don't care, I'm still gonna do it. All right, so diagonals AC and BD intersect at E. If AE is 5, AE is 5. What the hell is AE? Oh, they all intersect at E. This is E. Haha, nice. Sorry, Becca. Okay. 5. Then it says that BE is 12. Okay, 12. What is the length of AB? AB. Whew. How am I gonna find this? You know what? I'm gonna have to go back to the properties of the parallelograms to see what's up with the rhombus. Oh my God, look at this beautiful thing. Well, look at what I found. Okay, I'm gonna zoom in so you could see what I'm seeing right now. This is the rhombus. See that? And what do I know? Perpendicular diagonals. That's all I needed to know. So if in the rhombus I have perpendicular diagonals, that means that this is a right angle. And if this is a right angle, then this becomes my hypotenuse. I'm gonna call it C for hypotenuse. Gosh. In a right triangle, if I have two sides, how do I find the third side? Bex, all you gotta do is exactly use Pythagoras. So C squared equals to A squared plus B squared. Okay. So now what? Now let's use the values. All right. This is the hypotenuse. And how did I know this was the hypotenuse? Because it was opposite to the right angle. See that? Okay then. So now let's just substitute. So C squared equals to, I really don't care which one is A or B. So I'm going to call the 5A and the 12B. So 5 squared plus 12 squared. So now C squared equals to 5 squared is 5 times 5. And 12 squared is 12 times 12. All right. 12 times 12. And now C squared equals 169. I'm not looking for C squared. I'm looking for C. Okay, so how do I undo a square? By taking the square root of that. So then C becomes the square root of 169 is 13. So C is 13. So guess what? When they say what is the length of AB, then the length of AB, then you write AB, the segment AB equals 13. As simple as that. Okay. Next problemo. Gosh, please tell me I don't have to draw another one. The diagonals of a quadrilateral are congruent but do not bisect each other. This quadrilateral is. Okay. So they are congruent but do not bisect each other. Take 30 seconds and tell me what the answer is. I'm going to pause the video. Right. It was an isosceles trapezoid. Nice. Okay, let's move on to this one then. Which quadrilateral has diagonals that always bisect its angles and also bisect each other? Bisecting the angles and bisect each other. Okay, 30 seconds. No, 20 seconds because you have the sheet of properties over there. So look at the properties. All right. Nice. The rhombus. Okay, let's move on. If I was to ask you to give an explanation, by the way, you would have to say, well, the properties of the rhombus are blah, 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 in which one of the properties says that, and, you know, diagonals always bisect each other, and it's also, and the angles. Okay. So here, given three distinct quadrilaterals, a square, a rectangle, and a rhombus, which quadrilateral, wow, I learned how to say the word quadrilateral. Okay, must have perpendicular diagonals. I'm looking for perpendicular diagonals over here. So take 20 seconds, come up with an answer, and boom. Okay, so yes, the answer is choice number 3. Very good. All right. Let me see. Oh gosh, we're dead here. All right. Let's take a look at this problem right here. So it says, which reason could be used to prove that a parallelogram is a rhombus? Okay. So diagonals are congruent. Sir, if you look at the square, the diagonals are also congruent. Okay. Opposite sides are parallel. Yeah, but in a rectangle, in a square, in a parallelogram, opposite sides are sleepy now. Opposite sides are also parallel. So no, this is not enough. I mean, it could be, but it's not. I need contundent. I need detail, and I need exact evidence that I'm certain that that is a rhombus. Diagonals are perpendicular. Okay. Okay, this could be a winner. Opposite angles are congruent. No, opposite angles are congruent in the parallelogram, in the rectangle, so guess what? Boom. This is the winner right here. Got it? Okay then. All right. In the diagram below, math is a rhombus. So this is a rhombus. Okay, and it has diagonals, and we already know what's up with the diagonals. They are perpendicular. All right, so ham. Where's ham? H-A-M. Where is this? H-A-M. Okay. It's 12. Oh, gosh. Why did I even bother if they were giving it to me already? And A-M-T. A-M-T. This angle right here. Okay. That angle right here. What is... Oh, that is the question. What is AMT? Sure. Okay, they want the angle. So let's see now. This is 90 degrees. So I already have 90. Okay. So if this is 90, that means that these two angles, okay, the whole triangle will be 180 degrees. But I'm not going to do 180. I'm just going to think about the following. If this is already 90, then I know that there is 90 degrees between these two, because the whole thing is 180, right? Okay, so 12 plus what is 90? Well, all I gotta do is 90 minus 12, and that I get 10 as 8. Okay, and then this loses 1, so it stays at 8, and 8 minus 1 is 7, so it's 78. Okay, so that's it. 78 degrees. The answer is boom boom, choice number 2, and I did show my work, so no complaints. Oh gosh, oh gosh, oh gosh, oh gosh, oh my God, this is a long lesson, but you know what, it's fine, we'll do it. Okay. In the diagram below, quadrilateral star, okay, is a rhombus. Okay, so that's a good piece of information. Now, they give us all the measures of each of the necessary things that we need to do in order to solve the problems. So the question is, find SR, RT, and a measure of the angle TAS. All right. So let's see. Let's start with SR. SR is right here. So this is a side. So what do I know about the properties of a rhombus? Well, all sides are congruent. So I put the hash marks right here to denote that they are congruent. The next thing is this. How can I find this measure? Maybe if all sides are congruent, that means that all sides are equal in length. Therefore, this side should be congruent to this side. Therefore, they have the same length. So I could just equal them to each other. So that's exactly what I'm going to do. So I'm going to put here SR, okay? I'm going to start finding SR. So how am I going to do this? I'm going to equal SR to ST. So SR equal to ST. Now, let's translate this to mathematical terms. So SR is 8x minus 5. So 8x minus 5 equals, and then ST is 3x plus 30. Okay, cool. So far so good. So now let's just solve. So when I solve, okay, so I have, let me add 5 to both sides. So I end up with 8x equaling 3x, and then since I'm adding 5 to both sides, this cancels out, and this one becomes 35. Next, I know I have variables on both sides, so I'm gonna subtract 3x from both sides, making this 5x. I subtracted, so it's no longer here, and that only leaves the 35. All right, cool then. What else? Nah, just divide by 5. And x is 7. All right, now what is x? Well, x is 7, so the length of SR is 8 times 7, so 8 times 7 minus 5. 8 times 7 is 56, right? So 56 minus 5 is 51. So the measure of SR, and I'm going to put it right here. Okay, SR measures, what did I say? 56 minus 5 is 51, so SR is 51. So each of these sides measures 51. And look at this. If x is 7, so 3 times 7 is what? 21 plus 30, 51. So yes, it checks. All right, cool then. So I found the measure of SR. Now to find the measure of, what else? Well, RT, right here, RT. All right, so RT, where's RT? RT, this is a diagonal. Wow, but I don't have anything here. Oh, but look, I have a variable z here, and this z and this z, they should give me a clue as what to do. What do I know about the diagonals of a rhombus? Are they congruent? No, they're not. This is longer than this one. So what? Oh, they bisect each other. They bisect each other. That means that they touch at the midpoint, making this segment the same as this other segment, and this segment the same as this other segment. So what I'm gonna do is I'm gonna try to figure out what these segments are, okay, in order to figure out this one. All right, so I'm gonna equal 3z to 4z minus 8. All right, so 3z equaling 4z minus 8. All right, so solve this equation. Whoever gets the value of z, then I'll give you 1 point. All right, take I don't know, 30 seconds to 1 minute to do it. Shouldn't take that long. All right, so you subtracted 3z from both sides, so you get z minus 8 equal, well, 3z minus 3z is 0. Then I add 8 to both sides, so z is 8. So the measure of RT, okay, is not 8. 8 is just the value of z. All right, cool then. So let's figure out. Here is, we have 5z plus 5. So I guess I have, okay, ET is equal to 5z, which is 5 times 8, plus 5. So ET is 45. So if this is 45, this must be also, this segment must also be 45. So I can say that RT equals 90. Okay. They didn't give me the measures like in terms of like units, in terms of like inches, centimeters, so I'm just saying it's 90 units. All right, what else am I supposed to find? Well, let's see. I'm supposed to find a measure of TAS. Where is TAS? TAS, this angle right here. So I need this one. All right, cool then. So I just need to concentrate on this little triangle right here. Okay. Now, what do I know about the diagonals of a rhombus? That they are perpendicular to each other. So therefore, this is a 90-degree angle. Oh, nice, Becker. You mastered this. Of course, I am the teacher. Okay, so this is 90 degrees. So therefore, between this angle and this angle, there must be another 90 degrees because the whole triangle has 180 degrees. See how I think? So that's exactly what I'm going to do. So this plus this should equal 90. So that's exactly what I'm going to write. I'm going to write 5y minus 2 plus, okay, and I'm going to put parentheses on them, right? Plus 9y plus 8, parentheses around them, equals 90. All right. Now let's just add the like terms. So 5y plus 9y is 14y. Okay. And negative 2 plus 8 is positive 6. And that's 90. All right. So the rest I leave up to you. Just solve the equation and tell me what the value of y is. I'm waiting for it right here. I'll give you 1 point if you whoever comes up with the right answer. Okay. So y, you're right. Y is 6. You got it. Now, the measure of angle TAS, the measure of this angle right here, TAS. This angle right here, well, all I have to do is substitute the 6 that I found here into the measure, algebraic measure of the angle. So this is 9 times 6 plus 8. 9 times 6 plus 8. All right. So what is 9? 9 times 6 is 54. You know what? You find the measure and I'll just give you the point, okay? Good. Excellent. So I can say that TAS, the measure of angle TAS, is 62 degrees. And that's it. As simple as that. All right. Let us move on to our next problemo. Ta-dum, ta-dum, ta-dum. Did I do this one? Yes, I did this one already. So I'm going on to problem number 13. Okay. If the diagonals of an quadrilateral do not bisect each other, then the quadrilateral must be A. All right. 10 seconds. And I'll give you a point if you give me the right answer. Exactly. It's a trapezoid. Why? Because here, they what? They bisect each other. They bisect each other. They bisect each other. Boom. They don't bisect each other. All right. Here. Isosceles trapezoid ABCD has diagonals AC and BD. Okay. If AC is okay, you know what? Let me just draw a trapezoid. It's an isosceles trapezoid, so I'm gonna try to make it isosceles. Boom, boom. Okay, just pretend that this side here is congruent to this other side. Okay, and the trapezoid's name is A, B, C, D. How do I know how to label it? Well, they're telling me that diagonal's AC, so I know that the diagonal looks like this. So they have to be opposite to each other, so I know where A and C are. All right, cool then. So this diagonal right here is 5x plus 13. And BD right here, this diagonal right here, okay, is 11x minus 5. What is the value of x? Woo! Okay, what do I know about the diagonals of an isosceles trapezoid? They are congruent. Therefore, I could set each diagonal to equal the other. Oh, okay, so then I just write it like that. So let me translate them. All right, so let's see if I can zoom in better. Okay, good, better. 5x plus 13, okay, equals 11x minus 5. All right, so solve this equation right now. Tell me what the value of x is, and I'll give you 1 point. Excellent. X equals 3. All right, so if you did it before I did, I gave you the point. All right. Again, in an isosceles trapezoid. So we have isosceles trapezoid. This time I'm going to try to be more accurate, so I'm going to start using the ruler, of course. It's not like it's going to help that much because I'm not doing it, you know, OD. All right, so this is going to be like this. Something like that. All right, so let's pretend this is an isosceles trapezoid, and now let's label it A, B, C, and D. Okay, so BC is 20. Okay, AD is 36. Okay, AB is 17. All right, yeah, cool. All right, the chicken crossed the road. What is the length of altitude of the trapezoid? Altitude, but altitude is perpendicular. Oh gosh. Okay. The altitude goes from one vertex and is perpendicular to the base. Like that. So I'm going to draw two altitudes because basically that's what this thing has. Actually it has infinite many altitudes. I could draw it from here, but this is going to be helpful. All right. What the hell? How am I supposed to do this? Well, look at the shape of these little things. They form right triangles. And why do they form right triangles? Because this is the altitude, and the altitude is always perpendicular. Okay, so what is the value of this? I have no idea. Think of it. From here to here, we got 20. But this is 36, so there must be 16 units flying around between this. Okay? So, and remember that these legs are congruent. So it's the same measure from here and here. So this is 8 and this is 8. We know that this is 17. All right then. When I see a right triangle and I see two measures of each leg, or two sides actually, I can think of Pythagoras. Oh, Bax, you OD nice. You should have let your students answer that, you dumb head. Okay, sure. So this is the right angle, this is the hypotenuse. So I know what to do. All right, so I'm going to use C squared equal to A squared plus B squared. Okay, deductive reasoning. Hello. All right, what is the hypotenuse? 17. So this is 17 squared equaling. I'm going to call this A and I'm going to call this B, okay? So equals to 8 squared plus, I have no idea what B squared is, so it's just B squared. All right, so now what is 17 squared? You know what? I'm nice. I'm going to do this algebraically first. I'm going to solve for B squared first. So I'm going to subtract A squared from both sides. Now, of course, you cannot do 17 squared minus 8 squared just like that. You have to rewrite it. So 17 squared minus 8 squared equals to B squared. Ah, okay. And guess what? Now all you have to do is you could just put it on the calculator. Watch. So I'm gonna write the square root of. Oh, wait. You know what? No, I'm gonna explain to you first. All right, so let's figure out what 17 squared is, okay? So 17 squared is 289. So 289, okay, minus 64, which is 8 squared, equaling to B squared. Oh, okay. Now 289 minus 64 is 225. That equals B squared. But you know what? The funny thing is that I don't want B squared. I want B. So what is the inverse of squaring a number? Taking the square root. Hello. So now, what is the square root of 225? Right. 15. And that equals to B. Okay? Because I removed the square. All right then, so now the altitude of the trapezoid, my friends, is, since this is B, then the altitude is 15. Wow, somebody's stomping on the floor. They're gonna kill me. All right, and basically that's it. So B is 15, and my choice right now is, my answer is right here. So you see, even if it's multiple choice, you still gotta show your work. All right then. The next problem is kind of funny because you have never seen this, and guess what? You're about to learn it. Ha 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 ha. All right. So it says, in the diagram we have a trapezoid, RSUT. RS is parallel to TU. Yes, they are. And X is the midpoint of RT. Okay, and V is the midpoint of that. Okay. Question is, if RS is 30, okay. XV is 44. Okay, what is the length of TU? They want this length right here. Question mark, or let's call it X. All right, so there is hello. There is a theorem that says that the length of the mid segment right here, the length of this segment is nothing more than the average of these two over here. Ha ha ha. Very funny. So how do I do this? I just said it again. The length of the XB, the mid segment right here, in other words, the length of 44, is determined by the average of, of the bases. This is one of the base, this is another base. So this is 30 plus X divided by 2, because there's only two bases, right? Oh, okay. So now what? So now I solve the equation. How am I gonna do that? Easy. You have a denominator here. So that's the first thing you gotta get rid of. Either by finding the common denominator, which in this case is 2, or by just getting rid of it. So 2 is dividing here. So I'm gonna put it on the other side, and it's gonna go to the other side multiplying. But if you don't wanna do that, all you have to do is multiply both sides by 2. Now, if you do that, that means that this 2 is going to cancel with this one. Now, 2 times 44 is 88. Oh, okay. So I'm going to I'm going to continue working over here. So I have 88 equaling, well, these 2 already canceled out, so that's 30 plus X. Yeah, make a mistake. Okay, fix it. 30 plus X. I have the thing in my mouth, sorry. Okay. Sorry, I had this little thing in my mouth. Sorry, my bad. So I was taking it off so I could erase it. All right, so let's solve for X. So X is equal to what? You tell me. Nice. 58. There you go. Because you got to subtract 30 from this one and from this one as well. And you get 58. All right, cool then. Now, let's go move on to the next problem. So what you're going to do right now is you're going to take a couple of minutes to think about it. Not a couple of minutes, like maybe 1 minute, and figure it out. Okay, they're giving me all the measures, and they want to know the length of the altitude. So they want to know the altitude. You could do it with a ruler if you want to. All right, so remember something. This is 12. This is 26. You already know that from here to here is 12. So figure out what from here to here is. And then you're going to end up with, oh, wait, and this is 25, so this is 25. They want you to find this. This is a right triangle. Remember that. So this is a right angle. And you know what to use. Okay, and if you don't, then you're going to have to refer back to this problem right here. See that? This is the problem where I use Pythagoras. So do me a favor and just figure out how to do it. It's the same thing. All right, let's do it. Notice here that I'm not figuring out what 25 squared is. I mean, I could have, like I did in the other problem, but there's an easy way. You could just put this in the calculator. parenthesis, nice. All right, so if you did it before I did, wow, I'll give you 1 point. All right, let's move on. Okie dokie. Let's see if I can read this thingy to you guys. Well, you already have it, but still, there's some people who they need to know what the problem is. All right, so in the diagram below, late is an isosceles trapezoid. Oh, okay. They always come up with some silly names. Angle LE is congruent to, I'm sorry, segment LE is congruent to segment AT. Okay, LE right here is congruent to segment AT. So then this is 10, this gotta be 10 as well. All right, cool then. What else do they want? This is 24, this is 40. AT is 10, yes, we know that. Altitudes LF and AG are drawn. We got the altitudes. What is the length of LF? Oh, okay, the length of LF right here. That we don't know. So you already know this is a right triangle. You see? We already did 2 problems like that. So you should be familiar with this. So the length. First, I got to figure out what EF is. Well, I already know that from here to here is 24. So from here to here, 24. So then what is this? Hello, 24 plus what is 40? 16, right? So then this is 8 right here. Of course, this is 8, but I don't know. I mean, you could choose whichever triangle you want to do to work with. It doesn't matter. So now this is a right triangle. So guess what I'm going to do? Hello, you guessed it. I have to use Pythagoras. You see, what you learn in algebra actually works over here. So then, remember, opposite to the right angle is the hypotenuse. So, how am I going to set this up? Well, so I'm going to use, this time I'm going to use a squared plus b squared equals c squared. Before I was writing it backwards, it doesn't matter. Okay, so let's label this. We already know this is the hypotenuse, so this is going to be c. I'm going to call this A, and I'm going to find B. All right, good? Cool then. So A squared is 8. So 8 squared plus, I have no idea what B squared is, equals C squared. You already know that I'm not finding C squared. I'm finding B squared. So I'm going to have to subtract. All right. So what is C squared? I don't know why I put C squared. And if you put C squared instead of telling me that I should have written 10 squared, then I don't know. All right, then, so I'm going to subtract 8 squared, so I'm going to get b squared equals to 10 squared minus 8 squared. B squared equals to 64. No. It's 100, because 10 squared is 100, minus 64. Then, I know that this is 36, so you know what? I'm just going to do it like that. So b squared is 36. I was just going to put it on the calculator by taking the square root, but I'm going to do it right here. I'm going to take the square root right here. Okay, so b is 6, because the square root of 36 is 6. And we did it right here. Now, please, when you take the regions, don't just write 6. Put answer. Or put the measure of b is boom. Or the length of LF is boom. Okay? Got it? All right. Next problem. All right. In the diagram below, EF is the median of trapezoid ABCD. Oh, okay. AB is 5x minus 9. AB, what the hell is AB? Right here. So this is 5x minus 9. DC is x plus 3. DC is x plus 3. You know what this is going, right? And EF is 2x plus 2. All right, so they want to know what is the value of x. Okay, so we know that this is the median, okay? Because it's telling you right here that it was the median. Hello, I'm not making stuff up. the median. And how do I find this? Well, you add these two up, divide by 2, and equal it to this one, because this is the average of the two bases. Okay, fine. Let's see if I have enough space here. So basically what I'm doing is I'm gonna take the top base, x plus 3, okay? If you don't have enough space, you could use loose leaf, okay? Don't worry about that. So this plus the other base, which is 5x minus 9, okay? Let me zoom in a little bit so you can see it. You can see the numbers that I'm writing. Okay, that divided by 2 should equal the median, which is 2x plus 2. Okay, remember something. You adding and then dividing by 2. So that means that to undo the equation, I just gotta multiply by 2. Okay, so let me add the like terms, and at the same time, I'm gonna multiply by 2. Okay. Alright, so, wait, hold on a second. Oh my god, I forgot the x over here. Okay, now it's 5x, sorry. Okay, x plus 5x is 6x. 3 minus 9 is negative 6. And I already multiplied by 2. I don't know if you can see it, but if I multiply this by 2, then this 2 disappears. And when I multiply this by 2, I get 4x plus 4. Make sense? Okay, now let's solve equations Beker style. How do I solve equations Beker style? Like this. You know you have to leave the x by itself, so I have x's on both sides, so I am going to take this 4x and I'm going to put it over here. You know what's going to happen. If I put it over here, I'm going to end up with 6x minus 4x because I subtracted 4x from here. And at the same time, I'm going to add 6 to both sides. So I get 4 plus 6. That's Beker style. If you don't understand, you could just ask again and I'll explain to you. All right then, so then 6x minus 4x is 2x. 4 plus 6 is 10. 2 times what is 10? 5. Or just divide by 2 on both sides. I really don't care how you say it. But the value of x is 5. Bada bing, bada boom, bada bum. Oh, okay. Good. All right, let's move on to the next problem. Okay, so we got this. Okay, so again, we have an isosceles trapezoid. We have the sides right here. They want us to find the value of x. Okay, how the hell am I going to find the value of x? What property will allow me to find the value of x in here? Come on, 10 seconds, think about it. What can I do? I'll give you 1 point if you actually give me the right answer. That's right. The legs, it says isosceles trapezoid. Okay, so basically, the legs are congruent. Oh, okay, even if the bases are not. The bases are just parallel. All right, so I just have to equal this to this. And look at this. I'm going to write it down. So I have 2x plus 5 equaling 3x plus 2. Hopefully that's 3x plus 2 and not minus 2. All right, so let us solve this Beker style. So subtract 2x from both sides. What do you get? Well, this cancels out, and this 3x minus 2x is x. Now, wait, hold on, this is a plus 2. Okay. Now, subtract 2 from both sides. What do you get? 3. Haha, I'm nice. Okay, then. And it says find the value of x, so that's the value of x. All right, let's move on to the next problem. In the diagram below, wait, hold on a second. In the diagram below shows isosceles trapezoid. Again with the isosceles trapezoid, like, come on, I already know this. So, they are giving me these measures. They want me to find bad to the bone right here. Bad, B-A-D. They want me to find this right here. How in the world am I gonna find that? Well, think about it. Go back to the properties of the isosceles trapezoid and tell me what do you think happens? Okay, so the leg angles are supplementary. That means that this angle and this angle measure, and they add up to 180. Yeah, but how the hell am I gonna know what this is? Hello, it's called isosceles trapezoid. Look at what happens if I was to extend the sides right here. You know what it would form, right? An isosceles triangle. And an isosceles triangle, what do we know? Well, the theorem says that angles opposite to congruent sides are congruent. Oh, shoot. So this is 2x. Yeah, you thought I was going to say something else. Oh, my God. Guess what? Now I got the answer. What do you think I'm going to do? Think about it. Correct. I'm going to add this angle and this angle. So 3x plus 5 plus, I'm going to put it in parentheses just in case, plus 2x in parentheses equal 180 degrees. All right, so solve this equation now, okay? Right now you are pros at solving equations. So find me the value of x. I'm waiting for the answer right here. Correct. X is 35. Ah, nice. All right, so we found our answer, okay? So let's move on to the next problem. Or did we? Did we find the answer? Give you 1 point. You got 5 seconds. Oh, you nice. Of course. So we have that the measure of angle BAD is 2x. X is 35. So 2x is 70. No, just 70. And now, that measure of angle BAD is 70 degrees. Oh, Bex, nobody can with you. Of course not. All right, then. So let us move on to our next problemo. All right. So it says, a quadrilateral whose diagonals bisect each other and are perpendicular is a... Take 30 seconds to answer that question. There you go. Yes, it's a rhombus. Okay, so what's going to happen right now is that the next problems, as you can see, they are of a different kind. They are proofs. I am supposed to prove something, but guess what? I have not taught you how to conduct a proof. So what I'm going to do is I am going to go into the next lesson, and then I am going to come back to these 2 problems. All right? Good then. So I'll see you on the next lesson.